Hello geographers, and welcome to this video on data analysis. So this is your second lesson following from your fieldwork. We have already presented your data, and today what we're going to be doing is analysing it. So looking at our Lyme Regis fieldwork, our main question was to investigate how effective are the coastal management strategies at Lyme Regis. So this is now our opportunity to look back and start to identify things within our fieldwork data that can help us conclude, which will be our next lesson. So in this lesson, what we're going to do is we're going to practice using the writing style team as an effective way to analyse our fieldwork data. Each of those letters stands for something, and it might be something that you've already investigated within some exam style questioning as well. We're going to be looking for some trends across our fieldwork data of environmental quality surveys, which was our main data presentation technique focus of last lesson. But we do also need to now look at our beach profiles because it's important that we make links across two data sets in our fieldwork. To begin with, we'll have a little bit of a think about command words used in your exams. You'll have seen the word analyse before, but at this point it's also worth knowing and recapping what it is to describe and explain. So pause the video now for me and then have a bit of a think about what each of these command words requires us to do and also how they are different to one another. If you're working in our Thomas Hardye School work booklet, you'll find that you have got some definitions for these words with gaps next to them, so you may choose to now put the correct word into the correct gap. Pause the video and then unpause when you're ready to move on. Okay, so let's run through each of these separately. When we talk about describing as a geographer, we often refer to it as just saying what you see. So in the context of our fieldwork, we might be now looking at a graph or a map of some sort. Talking about what this graph is about, what data does it use, but also identifying any trends as well. So here's an example of how we might use that within our beach profiles later in this lesson. Now, to analyse is to kind of go a little bit further within your description by drawing upon numerical or statistical techniques, so bringing numbers into the fold. Now, we also recommend that you are looking at manipulating data, and this is hopefully something you've been doing already in your theory lessons. Manipulating ultimately just means do a calculation. So talking about something doubling perhaps, or that something has reduced by a certain percent or a certain proportion, working out the mean or the range, something like that to show that you are working with those numbers to make some observations. And finally, as we analyse fieldwork data, we do actually bring in a little bit of explanation. Now, we're not going to work too much on that today because we're actually going to bring that a little bit more into our conclusions as we look back at our question. But it's really important that we know that this will form a really important part. So being able to offer reasons for the findings that we've obtained in our fieldwork is really important. We will talk about that a little bit today as well. So I just want to introduce to you to begin with the idea of writing an analysis of fieldwork as a team structure. So there's a really nice breakdown of a few sentences that you can use here to really delve into what your data is showing. The first thing you need to do is look for a trend. Is there an increase observed across a graph? Are you noticing that certain parts of your location are better than others? So looking for that observation of a trend. Now, what we need to do as well is give evidence for that, so data. So it's not just a case of saying this place was better than this place. We need to know why. What was the score in one place versus the other? So this is where you're usually bringing numbers from your data to exemplify the trend that you're talking about. Now, we don't always use A, but it might be necessary sometimes depending on our data set. It's important to acknowledge anomalies. Is there something that doesn't fit the trend that you have just spoken about in your T and that you have evidenced in your E? So acknowledging that geography is messy and there will be something likely that doesn't quite fit your overall trend. And the final thing is that manipulation. So calculating something, doing something with that data just so that you're not kind of regurgitating the same old stuff. You're talking about those trends and thinking about scale sometimes by talking about, for example, potential increase in data. Okay, so we're going to try giving this a go. And what you can see on this slide now is we have got a snapshot of what you will find in your workbook if you are a Thomas Hardye School student. So what we've got here is we have got our team, almost like a bit of a kind of structure strip down the left-hand side, and we've got some space to write our thoughts. So we're going to first of all be thinking about the following, which is almost a sub-question of Lyme Regis being effective overall. So we're going to look at our environmental quality survey data again and think about which of those 5 sites was the most effective area of coastal management. If this is the video that you're watching after watching the previous one, you'll know that we've actually already spoken about this a little bit. What I would like you to do now is pause the video and use the structure strip on the left-hand side to write in full sentences an analysis of your data, focusing on which site was the most effective area of coastal management. Pause the video now. When you're ready to run through things together, then join me again and we'll do that afterwards. Okay, so let's have a bit of a look at what you could have written. Now, it's not to say that what you've written, if different, is wrong, but this is the sort of thing that you could go for. Note that I'm using the data that was used in the previous video for a particular student. It's likely that your data from this point onwards in this video might look slightly different. I'd like you to work with your data because you will know the reasons as to why you have given things certain scores. So use this as an example. So I've tried to colour code into the different kind of team elements. There is no anomaly in this one actually because we are looking at top and bottom. So if we have a little look at the T for trend, we're looking for the most effective coastal management, and that was according to the student's data I was using at the groin, which was location 4. Then we then need to evidence that. So have you put some numbers in to support your trend? The total score for this location was 29 out of 40. So overall score given. The site scored particularly highly for its access to the beach. So I'm now giving examples of where in the data set as well it scored particularly highly. So giving a bit more of a dimension and evidence to the trend that I observed in purple. Now, skipping that anomaly and now looking at your manipulation, it's all about doing something with the data. So we've got here that the museum scored the lowest. So we're now looking at a comparison. So it was 6 points lower than the groin. There's your first data manipulation. We've worked out a difference. The mean criteria for the groin was 3.5 out of 5. So that was what on average it scored for all of those 8 criteria within our survey. Whereas the museum only received a mean criteria score of 2.9 out of 5. This is a difference of 0.7. So you can see here in red that we are still using the same data, but we are changing it. We're showing the comparison of those 2 sites by manipulating it, working out differences between those 2 areas and their criteria. If you need to, pause now, have a little look back at your own answer and see if you can just improve it a little bit beyond your first attempt. If not, come with me now onto the next slide and we will move on to our second point. Okay, so whilst it's important to look at which part of Lyme Regis has been the most effective, actually we're looking at Lyme Regis as a whole in our main question. So it might be useful to think about in which way is the coastal management the most effective. So is it that it is super, super attractive? Is it that it's been maintained really well or it still provides access to the beach? So looking at each of those criteria, you are going to need to now look at all of your 5 sites and work out a mean score for each of those criteria based upon your own answers. Pause the video now and give that a go. And when you're ready, I'll show you what I got for the data set that I was using. Okay, so this is what this student came up with. You can see, of course, we're going to end up with decimal places because we're working out a mean. So I've totted up all of the erosion marks across my 5 sites and then divided it by 5 and ended up with 4.6. Done that all the way along. And as you can see, we've got a range of mean scores for each of these things. So already I can start seeing which parts of the coastal management criteria Lyme Regis seems to be doing particularly well in. I can see that, of course, we've got erosion and overtopping. They're the highest, aren't they? They're almost full marks for those ones. And then we've got some lower down ones. So let's have a look. We've got attractiveness and risk. So the student whose data I've used has actually felt that, it's not actually that attractive, potentially creating a little bit of risk. So, whilst it's been really good at stopping those coastal processes, they felt that actually, there was some disadvantages or limitations associated with perhaps the social use of the area. So again, we'll do the same thing by following our structure strip of team. If you want to pause now, give yours a go using your data, and then I will show you the sort of thing I wrote for this data set. Okay, so let's have a little bit of a look now at what you could have written. And of course, I must say again, use your data, use this as an example and adapt yours accordingly. So having a look at our T, so which criteria had the highest score? So reading through, so protection against erosion was the highest criteria score, in addition to the effectiveness against overtopping. So I've identified both of those. They were 4.6 out of 5, which is really high. 3 of these 5 sites actually scored 5 out of 5 in these criteria. So that's something to note as well, that actually some of those sites that we chose, this student has actually given top marks for overtopping and erosion. Again, this doesn't really suit the conversation of anomaly, so we're going to skip past that one a little bit for now. Now, manipulating data, we need to kind of maybe compare to the lowest. So we identified here that attractiveness and risk scored the lowest in terms of criteria. So I've put some numbers there and I've worked out a difference. So that's 2.2 difference in terms of the score between the kind of highest and lowest criteria successes. PAR, obviously protection against erosion, and EAO as effectiveness against overtopping. So actually what we might end up talking about, should your data support and agree with this, is that actually it's really effective. The money has gone into making this thing really work for the purpose of protecting Lyme Regis. But there are perhaps some other things that haven't been considered in the same way. You might argue that you can't keep everybody and everything happy. So that was always going to happen. But that's a conversation for our conclusion. Now, something else that you did on your fieldwork day is you looked at beach profiles. So you can see to the right-hand side of this screenshot of Lyme Regis, we have got the cob. So that was where you will fondly remember we stopped for lunch, but also that was our one of our sites, wasn't it, as we were doing our environmental quality survey. We then moved over into Monmouth Beach, which is the beach that you can see in front of you now. Now, this beach here is unmanaged in the simplest sense, but actually it is impacted by the coastal management because, as you have probably discussed with your teacher, the cob acts as a groin, doesn't it? It's stopping sediment, in theory, moving from Monmouth Beach over into Town Beach and therefore disappearing into the big old Dorset sediment cell. So what we're doing here, and what you did in your fieldwork, is you looked at the shape of the beach to identify whether longshore drift was having an impact upon it and whether the cob was successfully holding on to the sediment to stop it from disappearing. So you did at least 3 beach profiles as a class. You'll have done one, first of all, actually, by the cob, because that's where your teacher will have gone through things with you. You then will have moved to do a central one, and your class will also have done one much, much closer to the left-hand side here, so the western end, where you have got those cliffs. So if we have a look at our beach profiles as line graphs, let's see how those beach sections actually looked different. So if we have a look at this bit here to the west, it makes sense because the prevailing wind, of course, is going to be pushing from left over to right in this diagram. So we'll start with the left. You can see here that the beach is quite steep, I suppose, but it's not very long, is it? It is much narrower than what we expected to find in some areas, which is why your data sheets went up to 50 metres. So this student or group of students from whom I have stolen this data actually had to stop at 30 metres because it then became unsafe. You were pretty much at the cliffs. If we compare that to the middle of the beach, can you now see how that looks different? We've still got that quite steep bit here, which might suggest actually that there is quite a lot of storm energy coming in and destructive waves scouring away from this bit, because remember, this bit is the prevailing wind end side of Lyme Regis, so it's not going to be protected by lots of the things we've seen in our environmental quality surveys. If we then look at our final section, look how different that looks to the first one. It is much, much wider. It is steep. It's got these kind of lumps up here, which you hopefully discussed on your fieldwork day as storm berms. So we've got a very different looking beach here. Now, what this is showing us is that we are looking at a drift-aligned beach, which is a bit of an A-level word, but I'm going to throw it in there anyway. What that means is that we have got longshore drift acting upon the beach. It's picking everything up from the western side near the cliffs, and it's pushing everything over to the eastern side next to the cob. Now, what that's showing us is that the cob is working. It has made this part of the beach much, much wider by collecting all that sediment and not letting it escape. If it had escaped, we would be looking at a beach that looks like this left-hand side one along the entire thing. Another thing we can talk about actually in terms of justifying the coastal management scheme is the fact we do have a really steep bit at the front of the beach, which suggests destructive waves and a need to protect Lyme Regis, and also these storm berms at the back here, which are suggesting that during really intense stormy weather, this area has rocks flung all the way to the back of the beach. And of course, we don't want that in the area where the tourists are walking, so therefore the cob is actually stopping that from happening. So this data in itself is actually really in support of your cob location in terms of your environmental quality survey. It is proving that the cob is having a real impact, not just on everything downdrift of it, where you did those environmental quality surveys, but also stopping sediment from going further on as well on this Monmouth beach side. So let's have a look back at that team structure again. I'm going to give you a little bit of time because you're hopefully now going to pause, run through that structure strip as usual, and then we'll see what you will have come up with here. So these graphs should have actually been provided to you by your teacher if you are working in the normal school setting at Thomas Hardye. If not, what I might recommend you do is you take a little screenshot of this slide here, print it out and put it into your notes so that you've got it for reference. Pause it now. Have a little look through this structure strip and unpause when you're ready to go through it together. Okay, so let's look at what we could have written. You'll notice that this looks a little bit different for two reasons, which I'll explain as we go through. So when we're looking at our trend, we're looking at the idea that the cob is effective at stopping longshore drift. There's lots of evidence, so now going into the green, first thing is that the beach becomes wider as we go closer to the cob. So that's suggesting that we've got that build up, isn't it, of sediment. We've got some data there to give evidence of that. You'll notice I have actually brought the manipulation earlier here because this is actually the better way to do it, to manipulate every time you use a bit of data. So if you do become confident with team as a structure, try and bring that manipulation bit a little bit earlier if you can, rather than leaving it until the end. Another observation is that the beach is also much steeper at the cob end as well, and you can see that I've got data there and I've worked up that there's a difference in height from one side of the beach to the other in 4 metres, suggesting that sediment has been building up close to the cob. We're going a little bit into explanation there, but I think for the purpose of this activity it's worth it. Now, what you need to do, as I mentioned at the start of the video, is you need to be able to link two data sets. So this is where the cob is really important. It's almost like your portal into talking about your environmental quality surveys. So the beach profiles have proven that the cob is working. It's stopping longshore drift from taking that sediment. It's also stopping those big storm waves, which are clearly impacting Monmouth Beach, from doing the same thing in shaping the rest of Lyme Bay, where we want those beaches to be quite safe and remain quite stationary for the purposes of tourism and protection of the town. So a little sentence you might write here: the Cobb End beach profile also shows 2 storm berms. This justifies the building of the Cobb, as storms clearly occur here frequently in areas not protected by the Cobb. Okay. So if we have a little look back at what we've achieved in this lesson, hopefully you are feeling confident in the following things. Giving that team practice a go. We haven't actually used the A very much today, but it's worth knowing that it is often there. You'll probably have maybe used the T method before in your exam skills, so it's worth just reminding yourself that anomalies can be there and will sometimes matter. We've also looked at trends across our fieldwork data in support of our conversation about effectiveness of coastal management. So in what way is Lyme Regis effective as a coastal management strategy? Which parts of Lyme Regis are the most effective? But we've also made a link between 2 data sets. In the beach profiles, further prove that the Cobb is an effective area with regards to overtopping and stopping those really big destructive waves. So I hope that was helpful, whether you are joining this video for catch-up, revision, or perhaps another reason. Should you need a little bit of support and you're a Thomas Hardye School student, then please do not hesitate to come and talk to one of us in the geography department about your work. Thank you very much for listening, everybody. Have a lovely day.